Recording. Morning again. Today is Wednesday, March 24th. This is the Kubernetes Data Protection Working Group meeting. Let me share my screen first. Apologies. Today, majorly, we have two major agendas, and then we'll leave to an open discussion. The first thing is that Xin and I have been working on this whole container notify cap for a little while. Today I'm gonna to give the group a more kind of look back plus current status updates. This will take probably 30 minutes of the session, depends on how many questions we have. The second agenda is we'll talk about a little bit about the white paper without updates. Then we will be opening the session to the audience. If there's any question or anything you want to discuss, please feel free to bring it up there. All right, let's get started. Let me bring up my slides. Okay. So you probably have been hearing this topic for a little while. Just to give those who are not very familiar with this topic a little bit background. So that in total, 2 attempts so far to define a mechanism to send a command to a container in Kubernetes world. The first attempt, the cap is listed over there. It was CRD based. Controller will reconcile on the CRD, and it needs to be a privileged pod because it needs to run arbitrary kubeexec command against arbitrary pod and container. And it mainly was targeting at solving the application consistency snapshot problem. That was the first attempt. And there were a couple of concerns around that. One biggest thing is about the security, because the controller needs to be privileged. There were good amount of pushback from Signal and also API reviewers talking about the possibility of moving this into a different direction. The other thing is that this seems to be a good. There are other use cases which can fit into this model, and they want to extend the scope a little bit, so that use cases like sending signals to a set of containers or pods in the Kubernetes cluster, when, for example, if you want to debug, you send a signal to adjust your log level. And from Signal, there's another thing called when they try to tend a node or mark a node as unusable, unschedulable, they want to kind of notify all the pods that are running on that particular node to let them know if there's anything they need to handle, should handle this right now before they mark the node down. So those are the cases. Then Xiangqian and I went ahead and proposed this container notifier. It was core API based. Kubernetes will run the command against the pod and the container eventually. This basically is the main purpose is not to widen the scope of privileged controllers that offered by the community. Kubernetes already have all the necessary access to run those commands against any arbitrary pod and container on that particular node. And that is also to support more generic to support other use cases. And this is a second attempt. But we received a good amount of feedback from the second attempt. So we had a couple more rounds of discussion. Then we had a second and third attempt. So deeply in this topic, what are the major concerns in this thing? Are three aspects. The first thing is scalability. So Kubernetes is it's already a very heavy, but undoubtedly it is really important core Kubernetes component. How do we make sure um, we don't send too much traffic to the API server from Kubernetes, and how do we ensure Kubernetes can actually handle so many notifications when the pod can be in the order of thousands in the cluster. The second thing that drew a lot of discussion is the whole imperative versus declarative concept. Kubernetes APIs are mostly, if not all, declarative, right? This whole base level triggering versus agent triggering, right? Everything is about level triggering Kubernetes work, and signal execution hooks tend to be more in parallel. Basically, you send something and you leave it there, let it run. There's not too much need in terms of retrying logic like a regular Kubernetes controller will be doing in case of failure. Taking the execution hook for application consistency as an example, even if we want to retry, or maybe we don't even want to retry, to limit the quietest period of a certain application, and while during application consistency snapshot process. If we introduce this retry logic, maybe we can still bound it, but admittedly it will extend the period or the SLA we need to quiet the application in case of failures. Signals is another good example as well. The third thing is that there are some interesting use cases where this whole deterministic sequencing or ordering of execution is desired. Application quiets and unquiets for sure. And when you send a signal, for example, if you want to temporarily adjust the log level to debug, you don't want to do this, you don't want to leave it there forever, because that probably will, write too much log into your system and make your disk full very soon. So how to deal with the newly created or newly deleted pod in the Kubernetes world, it remains a problem to be solved. Basically, pods can go and get deleted, can go and come at any time in the Kubernetes environment, even nodes. So how do we process that is another major discussion topic. Questions so far? No, then I will move on. So we have two attempts in the second attempt. This is the first attempt in the second attempt, the core thing. So the idea is have an inline container notifier, a list of actually container notifiers in the container core type. And this is not an API object, it's just an inline type. So the structure of the notifier is pretty straightforward. It's basically just a handler which does the command and the name. And the name uniquely identifies a specific handler to run. In a container, you can have multiple notifiers. Users specify this container notifiers during the pod bring up time or container creation time. So when a user wants to trigger a specific container notifier, they create a notification to trigger to request a specific container notifier by specifying the name, the notifier name, You can see the notification spec structure in the right-hand side, the second one. On top of that, they also specify which pod to be notified. So there's a pod selector as the first field, groups all the pods that qualifies, that has the label, and get all the, and find the corresponding notify within those pod definitions and send the kube exit command. So you can imagine you have, let's say, a MySQL deployment somewhere with the leader and the follower enabled. So when you do an application requires logic and application consistency snapshot, what you want to do is that, okay, you select all the pods that labeled with, let's say, MySQL, and then there's a notifier defined in the container, say, requires me, whatever it is, and then you send the signal to that corresponding notifier. And the results will be recorded in the notification status. You can see that the notification status, the first thing it has is a list of pod notification status. And each pod notification status contains potentially multiple container notification status, because each pod can have multiple containers, and all these containers can have that notifier defined. Is this making sense so far? So the major concern on this design, there are a couple aspects. One aspect is there could be thousands of pods in your cluster. How do you scale your notification status? Because your pod selector can be arbitrary, right? It can be anything. And then it may end up thousands of pod notification status nested underneath the notification status. First of all, it will create a good amount of pressure on API server and also Kubernetes in the future, because it needs to process every single of the resources, every single of the pod that qualifies the selector. Secondly, the notification status will group so big such that it breached the API service limit, the size limit. And you can no longer store all this status in the API server. So that's the very first concern. The second thing is, this is basically from Jordan Liggett. His concern was that, go ahead.
I had a question, if you don't mind. What is in the status? Is it just like the output of the command that got run?
In the notification container notification status, it contains a couple of fields. Originally, it was whether it is succeeded or not, at what time it is succeeded, and its corresponding container name, container identifier.
Okay, I'm looking at this design and trying to understand how it's different than just using kubectl exec with some sort of an RBAC scheme where the user who defines the pod basically gives a whitelist of commands that can be exec'd. Like it feels similar to that in terms of what it achieves. Am I misunderstanding some crucial notion or some crucial portion of this?
Sure. Though the key thing, you mean the security piece? Is that what you're talking about?
I'm wondering, like, if we just, like, kubectl exec lets you run commands, and the reason we don't like it is because it's just, you know, if you don't put any limit on the commands you can run, people can use it to perform attacks. So this mechanism lets the guy who defines the pod sort of enumerate a set of commands that can be run from, you know, from other controllers. But like, doesn't that function just like a white
functionalize? It is the same.
Yeah,
this is just there's a like security aspect of this, right? And also adding this as a pod definition makes it part of the Kubernetes, the core API object. Is just more convenient. Yeah, but functional-wise, you're right. It is the same. Achieve the same goal.
Okay.
Underneath, do the same.
I was going to say
the same thing.
For scaling, we have a solution to the kubectl exec issue, right? Like where if I wanted to run kubectl exec on 1,000 pods, like I would just do that. And I don't actually know how the API server stores the output of all those commands, but presumably it does it in a scalable way. So like I wonder if there's a way to just leverage what exec is already doing and then have this mechanism.
But you don't really, where do you save you're not really saving those in your API objects, right? The results. When you run that, where are you saving this? So you need to have your own controller take care of those, right? Here we are talking about, we're saving that in an API object status. So that's the concern.
Yeah,
so
I'm wondering if that's the right, because it seems to create a scaling problem. So like maybe we only need to store the stuff that is lightweight that kubectl exec would have stored if you had run it.
Well, kubectl does not save it. You have to save it somewhere in your controller. You need to create your own, maybe your own CRD to save that somewhere, right? So you actually have the same problem. I'm just probably your controller is handling in some way.
Yeah, I don't know mechanically how exec.
Well, exec doesn't really. It returns the results. You can run that from command line, returns the results, and then who is saving that? You're running on a command line. That's just dump that on a command line.
But you're
if
talking
you have a controller, then your controller needs to save it somewhere, right? So that's why I'm asking, what are you comparing with, right? The status update. Here we're talking about if this is part of a status in an API object, then there is concerns from the API update point of view. There's a
with kubectl exec, the client is talking to the REST server, kube API server from some client.
So what we are talking about here is not like running the command itself, but it's after you running the command, there are some results coming back, and then you need to save that somewhere. So tell me that if you're using it, where are you saving today?
No, I'm saying I don't know the answer to that. I'm saying
right. So we're talking about. I mean, we're talking about different things here, right? So if you run,
it's stored somewhere.
kubectl.
I'm saying why can't we reuse what it's doing?
So what I'm saying is, we're talking about we want to save that in an API object. It's not going to be saved somewhere. When you run that, you run that on your CLI, right? You see that's the output, right?
But,
your controller have to save it somewhere.
The API server is getting the data from the node to the REST client, and it's acting as an intermediary.
Fine. We're talking about that results has to get somewhere in the API object. That's what we're talking about here. When you're using kubectl, I mean, it's not really saved, okay? Unless you have a controller that saves it some way. So we are not really talking about the same thing.
I believe that it is saved on the node.
No,
by the container runtime.
Not. No, it is not.
So, hey, just want to intervene. I think this is Alay from Red Hat. I did a little deep dive into how kubectl uses implements log and exec, and from my study, kubectl exec opens a bidirectional connection from API server into the kubelet. Into the container. So the API server is just proxying that connection.
So how many containers are you going to log into at one time when you run that command once?
No, so that's a valid question. All I'm saying is, to your point, it just opens a bidirectional connection and it does not store that metadata.
Yeah, that's my understanding. Because I didn't run that command myself.
Okay, so thank you. I suspected it was something like that, and I know that for the logs they actually are stored on the nodes, and Kubernetes just has a way to go pull them out when you want them. But
right, logs will be there. That
yeah, but it's not in the API object. That it's not that easy for you to go parse the logs. That's not what we.
But okay, go ahead, please.
So if you are using kube, and also what I'm saying is we're talking about scaling issue, right? When you're running that kubectl command, you're running one command, so you are logging to one container at a time, right? Here we're talking about we're doing a program. Then when we select a lot of we use the pod, the selector, then it could be thousands pod, and we're running that at one time. So that's the concern.
Well, that's what I'm trying to get to, is that we're creating a new problem because this is a new, we're running a command sort of non-interactively, With kubectl exec, you would just get the output beamed directly to you and it's never stored. But like here,
but we need to, yeah, but we need to
we
get the
have to store
results, right? Well, you can, yeah. So you can achieve all of this by using kubectl, yes, but then you still have to figure out like how to store that yourself, right? So right today, I think like the backup vendors, some of them, they, well, I think most of them should be already doing this. So they have to handle that themselves. Maybe actually we should probably ask someone to answer this one other than we talk about it.
Except
I
you
know
don't
if
actually need to store the output. You just need to receive it and process it and then make it and then determine whether
right. So we need to get that.
success or
We need to
failure.
get that result somewhere, right? We need to get it.
Yeah.
I mean, so
Yeah,
the problem is
I'm not trying to criticize the design.
No,
It's a
no,
bad design.
I'm just
trying to understand.
I'm just
what-
saying. What I'm trying to say is that the problem is the potentially you could have thousands of pods. So I think the concern is the scalability. I think that problem actually exists today. If you are doing if you're quiesce and then you actually have to quiesce thousands of pods, you actually also have that problem. It's just, it's not, maybe not an API update, and I don't know, your controller maybe handle it differently, but it should have some similar scaling problem actually.
Which one we're talking about?
So we're trying to talking about, Ben was saying the scalability problem is already resolved by kubectl. I'm saying it is not. It has the same problem.
I'm not,
so maybe,
making that
okay.
argument.
So maybe actually, Tom, I don't know if saying Tom, you guys are already doing this. I think it might be better for you actually give an example, because otherwise maybe we're actually going into different directions, but actually it's the similar problem.
Yeah, so the way we tackle this is the kubectl exec libraries return 3 values: standard error, standard out, and error code. If there's an error code, we treat that as an error and then update the status in whatever CRD or API object we return back. And the actual standard error and standard out, we log in the controller, because it doesn't actually show up in the pod log itself. So then we essentially stream all the data back to the pod and then put it there.
So what happens if you happen to have like 1,000 pods that you have to quiesce? Do you have?
Typically, we don't see 1,000 pods because we kind of tackle individual applications, right? So if you have a namespace.
So what is the typical size? I mean, like what is the typical or the largest that you see in application?
The largest is up to, I would say, up to like 40 pods.
40
probably.
pods, okay.
But average is much less because usually it's like kind of a some like MongoDB or something where you have to go and execute in different.
Right. So probably in practice, this is not really a problem. Maybe.
No, it's not. Even in practice it is, right.
Xiangqian, I'm talking about the quiesce case. So maybe, but since we are making this more generic,
like signal, right?
With signal it could be,
concern.
Yeah. So in that case, then you can say that we are enlarging this problem because we are making this more generic.
We are only solving the application snapshot problem. I don't think scalability is really a concern because, as Tom was suggesting, normally you won't have over, let's say, a dozen of pods for a specific application that we need to quiesce. But if we are talking about signal, then this is a good chance we will breach the thousands. We're getting into the thousands kind of domain. Tom, you were saying something? Sorry.
For the signal case, you won't have that much output being sent back, though, right? I mean, because you're essentially just running a single command that won't have too much output, unless what output are you thinking you'll have to collect from sending a signal to 1,000 pods? Sure.
Even we make the container notification structure as concise as possible. If I didn't do the math wrongly, only if you contain let's say 16 bytes of ID, it will explode. If you get like 5,000 pods.
Yeah. Okay.
And I think this is a valid concern in many cases. So let's say we have some kind of solution. Let's see whether we can solve this problem. But I want to discuss with Ben offline a little bit on to get what his idea is, because I'm interested to learn about that. Ben, I'll pin you later on.
I don't have
Are
a
you
specific.
is it clear now, Ben? Maybe after Tom explained, maybe it's now more clear.
No,
I don't
Xiangqian-
think he's arguing about that. He was saying, are there alternative ways that we can save this status? We cannot using this status at all. I don't think he's doing that.
I was trying to figure out if there was something else that we could leverage and why this feels like a new problem when fundamentally what we're doing is something that people already do. And I think we understand now it's because we're not in a position to directly stream the results of these commands. So someone has to buffer them somewhere. And that's where the problem comes from.
I think it's an existing problem. It's just
have we considered a model where there's like an object per pod? So instead of having a giant array, you have just a bunch of objects, and so you scale by.
That leads to the next slide, maybe.
Did you read my slides or you? Okay. Okay, that's the first attempt. So we collect this feedback. Did I talk about other feedback we have, Xin? Like
I think you covered it.
Right.
I think you have covered it.
Just one question. So here, basically, when we create notification to request triggering corresponding containers, it's really kubelet that triggers that, right? In container, right?
Kubelet.
Yes, kubelet will be that.
Yeah.
Yes.
I think back to the previous discussion. I think basically the problem here is this has the potential, for people to use it however they want. So outside of snapshot use case and quiescing, people can use this like Ansible, just to run commands at a bunch of pods, which can be more frequent than running application consistent snapshots. Or as far as scalability, I think it's same as the Kubernetes model where people just write custom controllers in their pods, and they're watching and updating CRs. So I think what this enables is that people don't have to write custom controllers. They can just abuse this mechanism to, run commands across a bunch of pods, kind of like Ansible. You just unleash the command on a bunch of nodes. I think this is where scalability can get affected. People use it for other purposes that, it's generic, so we wanted to use it. Let people use it however they want. So I think that's where the problem would come in. The fact that it's now.
That's basically the point.
Yeah.
That we're trying to make. Yes. Again, if it's purely for application snapshot use cases, I don't think the scalability problem is there, because the application owners will be the ones defining the pod selector. They will also be the ones who label the pods the way they want it so that the correct pods are selected. And they will be also the ones defining the execution hook commands. So if this is a purely kind of application consistency snapshot use case, then I would be less concerned about the scalability. But extend this to a more generic way opens the door at least.
And how does this proposal solve the kubelet being the bottleneck problem?
Can you repeat the question? Kubelet being okay.
So in your previous slide, you had said basically kubelet is already bloated. It does too much. And
no, this proposal brings that problem. This proposal brings that concern because Kubernetes is already kind of busy. So it is possible that many pods are scheduled on a node. So having Kubernetes to run all these notifications in once, I'm saying not necessarily for sure, but may bring an too much burden to the Kubernetes. It doesn't solve the problem.
It doesn't solve the problem. Yeah, that's what I want to make sure. Okay.
Yeah, it brings the concern.
Okay, great.
So we discussed it, and Xin and I, we had a couple of rounds of discussion with API reviewers, etc. And then we come up with the second attempt. Okay. So the container notify pace doesn't change. So it's still gonna be inlined. But instead, we introduced this pod notification spec as Ben was suggesting, just one-to-one mapping, right? And this pod notification status will contain container notification status. Again, a pod can have multiple containers that match a specific notifier. And it not only contains the status, but also have some high level, pod level aggregation results like completion time, start time, succeed or not. I will explain why we need this slide later. So result you can imagine is you create a pod notification and all the results will be stored in the pod notification status. And this limits the pod number to 1 in this specific pod notification. Then on top of that, you have this notification spec. Or again, it also have a selector. Majorly, this thing is for user-friendly cases, especially for Signal. You don't want to manually send every single signal to every single pod using pod notification defined above. That is not gonna just scale. And also high-level controllers may utilize this one. But on top of that, we add a couple of things, two things majorly. One thing is this whole policy thing. It defines when should this selector should cut the scope. So right now there were two possibilities. One is all pods. Basically, the controller will keep on reconcile on this notification object. If a new pod get added, it will be claimed by the controller under the all pods policy, and get a pod notification will be created for that pod. And the other policy, for example, is called pre-existing pods only. It means that at the creation time of your notification, this is the time that you mark in the API server for your notification object. Use that timestamp to find any existing pods that is up and running, which have a smaller timestamp than the notification creation time. This way, any newly created pods after the creation of the notification will not have a pod notification created. That's basically, this is majorly to solve the problem of having a fixed scope and ensure ordering of execution for commands in pair, especially for the quiet and unquiet case and some signal cases. Another field we add is called parallelism. If you're familiar with the jobs or batch jobs API, you will find the parallelism, the similar mechanism over there. This is majorly targeted at avoiding users from creating a bunch of jobs, let's say 1,000 jobs to be kicked off at the same time, which crash the system. It has a limit of how many concurrent ongoing pod notifications you can have for this notification object.
There's a question in.
Sorry, I can't see you raising hand, etc. Please just speak up.
There's a question. What about deleted pods?
Okay. Question about delete pods. There are two things to think about. One thing is that if you think about in this mechanism, that if a pod has been deleted before the notification is created, so it's not up and running, there's no problem. The problem happens when the notification is created and they already sent a pod notification to a pod, and the pod executed, and then later on get deleted. Then later get deleted. In this case, if either the pod notification will fail, or it will succeed, right? The result should be deterministic. But the problem is in the paired execution case where the first part a notification actually succeeded for quiesce, let's say use fs freeze. And the second, before the second one is sent, the part get deleted. Then your file system may be locked in this case. I have to be honest with you, we don't have a solution for that. This is something we're still thinking. At this moment,
So if it's deleted, then we should just fail. Well, depending on what it. If we're doing quiesce, then we should just fail that quiesce, right? Because otherwise, what's the point?
No, it is possible at the quiesce time the pod is still up and running, right? And then if you imagine a upper level controller say, oh, now quiesce my application, no, get executed. You go ahead and do a volume snapshot or volume backup or your application backup, whatever it is. It takes some time, right? Before you execute unquiesce against the pod get deleted.
Okay.
And then your pod notification will not reach.
Yeah, that will fail. Basically, that's going to fail. We still need to run unquiesce, but then this whole thing
will fail.
Should fail, right?
No, you can't. You cannot fail because it's deleted, so it's not in your scope.
But then, okay, I'm not sure how. Okay, I'm not sure what this means.
So I think what I was getting at is like, are we going to take ownership then of the pod when we start running notifiers?
That's a great question. So basically what you were trying to say is that you maybe put a finalizer on the pod saying that do not delete it, etc. That's a good question, but how do we know this?
Yeah, I don't think we are in the position of doing that. That's just too much overhead for us.
It's not only overhead, but also how do we know there's an upcoming comment, right? We're talking about the comments in pairs, right? Which will have this kind of split brain problem where the universe is different. I did have a different proposal before, which is to have a recorded list of pods that have a specific pod notification executed. In that case, I can imagine the way a viable approach is upper level controller creates sees a notification object, and it creates pod notifications, right? And a pod notification to pods are one-to-one mapping. They're one-to-one mapping. So let's say this is a quiesce. And when you do an unquiesce, you should be expecting exactly the same universe of your quiesce command. I guess we need to leave some kind of this coordination logic to upper level controllers. From this notification specific level, we probably won't be able to solve that problem. Did I answer your question, Shirley?
I think so, yeah.
Okay, the last piece is that notification status will no longer hold a gigantic list of pod notifications and container notifications results, but rather it offers high-level aggregates. The completion time and start time are both kind of optional in this case. The completion time will only be marked if the policy is pre-existing pods only. Imagine the world, if it's all pods, you will never have a completion time, basically. Okay, that's basically the current AP, the second attempt of the second attempt.
Xiangqian, I had a question about the all pods policy. Then you say that it doesn't. We never record a completion time then, but does that mean that in effect is a notification policy that's in effect forever, so that any new pods that come in, that notification spec will immediately take effect?
That's correct. So
the expectation is that the application that's triggering the notification will at some point decide enough's enough and delete the notification spec?
That's correct. By saying that, if you say all pods until the notification is deleted, any newly added pods which match the label selector will be notified.
Okay, thanks for the clarification.
No problem.
So one question. So in phase one, we talked about the pod notification object, which is used to basically specify the pods we want to notify. And then in this phase, we're adding a new abstraction called notification, right, on top of pod notification to cover different pods, right? So we are basically just making scaling problem more kind of worse, because we're now expanding it beyond just a specific label. We're expanding to multiple like labels across different pods, right? I mean, I understand like we're not controlling it, but specifying the parallelism, but users can still configure it however they want.
No, there's a key difference over here, right? The first difference is this whole notification controller logic will not be in Kubernetes, right? So in this case, Kubernetes will be not the ones selecting the pods to be executed. That's one. The other one, and then it is at least somehow shift the concern from single nodes to more or less upper level controller. Where this is, I don't know yet. That's one. The second one is the aggregated results it's recorded instead of detailed ones in the upper level notification object. So pod notification will have a per pod status, and notification will own all the pod notifications created out of it. And then if anything wants to see a detailed drill down, they can always get it. That's the second thing. So there's no.
My point was that doesn't reduce the load on API server.
So
in fact, we're adding, because now we're also adding the aggregates to whatever we were capturing before.
I agree, but there's a difference between a user shoot themselves in not shoot themselves, but a user intentionally to break the system versus whether we provide a mechanism to them to prevent that from happening, right? The parallelism mechanism is there to prevent that from happening.
I mean, if the parallelism is something that can get controlled by the admins of the cluster, then yes. But if users can specify them, then it wouldn't do much, because users can.
It's the same thing as jobs, right? If a user can create jobs, it's the same thing. You can, as long as you have the namespace access, you can create thousands of jobs on the same time. I guess the mechanism is very similar over here. You as a user of your cluster, you can always kind of find a way to just screw it up, I guess.
I mean, I guess the way we currently control that is that we have quotas per namespace. So we can, for example, prevent the user from creating too many pods or too many PVCs, or launch a denial of service attack. But here, if users can set their parallelism field to arbitrary large values, then nothing can. I mean, basically, we're just hoping, the other quotas would kick in, and for example, the pod quota would kick in and prevent,
There's all,
yeah.
To maybe this will help relieve some of your concern. Is there was also a discussion around whether we should set an up limit for the parallelism, basically providing a range that is enforced by the controller. The range can be some number like, for example, 100 or something like that. But this is, it's really hard to decide what number exactly we want to put it over there. Basically, put a bar or maxed number of pod notifications that you can spawn from a notification object. But fundamentally, you're right. Yes, parallelism only gives them the mechanism; it doesn't prevent.
Mm-hmm. And just to clarify, so here you're saying it will not be in kubelet. We're still relying on kubelet for the pod notification updates. We're just not relying on kubelet for the aggregate notification updates, right? Through the new controller. Right.
You are absolutely right. So we imagine this to have multiple cases, right? So we imagine the application controller, most likely it is reasonable for them to use the pod notification directly so that they can control the universe. For queries, you have this universe. For unqueries, you have another universe. They don't necessarily need to rely on the notification to achieve that. And the notification then is a more suitable way of kind of selecting relatively large scope of pods to run, let's say, a command or signal, or send a signal, etc. And this is more like a user-friendly thing. Again, to the point that previously brought about by Shirley, this is basically for the application consistent snapshot use cases. I think it's still better that the application controller can have fine-grained control over which parts to notify and which part to not notify.
Yeah, thank
Anyway,
you.
no problem. Anyway, we're at 51 minutes mark. So any more questions on that? By the way, the caps are listed in, and I already shared the slides. All the links are there. So if you're interested, please take a look.
I had a question about so obviously the notifiers have to be at the container level because different containers might want to run different commands in response to notification. Have we thought through if notification should always be at the pod level, or if it should be valid to like notify just one container of a pod? Or like how do we decide that granularity, whether to do it at the pod or the container level?
First of all, the command has to be executed against the container, a specific container, right? That's one. So the defining the notifiers in the container level, that makes sense, right?
Yes. Yes.
So your question is, why don't we go ahead?
Yeah, the notification, should that also be at the container level, or should the notification be at the pod level?
The second attempt, it's in the pod level. So it shouldn't be in okay, let me give you an example why. First of all, there could be multiple containers within the pod, right? They do different things.
Mm-hmm.
However, it's totally possible that they all have same notifiers defined, especially for the signal case.
Yeah.
Right? If you define in the container level, you still need an identifier to find which container it is within the pod. So you need the pod name anyways, you need the container name anyways.
Well, but in this design, you don't need the container name.
Right, if you define in the container level, you don't need the container name. You only need the pod name and the notifier name.
Right, well, I guess that this proposal makes it like if I have two containers in my pod and they both have a notifier with the same name, and then I want to run a notification, I have no way to run it on only one of the containers. I'm forced to run it on both, and that's by design.
Oh, that's a good question. I honestly haven't.
That is actually by design. So why don't we share the tab? Actually, we have some comments there.
Which tab?
The tab for the container notifier. We actually have that explained. Notifiers, the name of the container notifier trigger. So it's basically just based on that name. If you.
What is the comment? I didn't know that.
Just go to the cap itself. Just go to files. Go to the cap itself when it explains what is in the container notifier. That over there. Basically, the API definition actually will have some explanation there. Right. So yeah, so this is a container, right? So we're adding this container notifier. And then in each container notifier, so in each container notifier, we have this name. So this name, right? So this one, so basically the container, these container notifier in the container must have a unique name, and then you move down a little bit. I think it's move down.
I don't think we discussed this.
Oh no, it is that it's actually it's basically well, I need to check this one. I haven't had to look at this one for some time.
So if they're
Yeah,
the
so
same
there is
name,
no way.
Oh,
So,
sorry.
yeah, so there is no way to differentiate that, Ben.
Okay.
So if
I
it's,
just wondered if that
that's
was
a
intent.
that's by design, yeah.
But why? Like you're making something impossible that we could easily make possible, and I don't see the advantage.
So okay, so maybe you can give a proposal on suggesting on how you want to differentiate that.
Well,
we would just add an optional container name field that if you specified it, it would only notify that one container.
That one container.
Right.
Yeah, but
if
that's
you,
not. It's yeah. Normally, it's possible, but normally I think that pattern.
let me think it through,
Not that-
Ben, firstly. That one I have to be honest with you, I haven't thought through that.
What's to
potentially-
keep the two different containers from just using two different notification names? If the intent is for a notification to be delivered to a specific container for a specific reason, does it make sense that both the containers would use the same name for the same reason?
right. There's both use cases. You may want the ability to just broadcast a message to all of your containers and all of your pods, in which case the convenient thing to do is define your notification with the same name on all of your containers. But then you may have a different use case where you want to just do a one-off, and the fact that you can't target one container forces you to like make a second notification that runs the same command with a different name or something lame like that.
Yeah, I also have another question, I think, while we're talking about this. If I can have 3 containers and each container has a container notifier with the same name. I would create a pod, the notification spec that says, go run this notifier in that pod, and I would just get a success or failure. Could it fail for one container and pass for the other 2 containers?
It can completely fail on some of them and succeed on some of them. That's the reason why we have a list of the results.
Do we have a, sorry, maybe I missed it. I thought the notification status was just a.
No, it's a list.
It's a list. Okay, never mind. I apologize.
No problem. It's here. See, the status is a container notification status. But Ben's point, I think it's a valid point. The typical case I can think of is you have multiple pods in multiple containers in a pod. Maybe some of them is the main container you don't want to mess up with, but you want to adjust local levels with other containers. That seems to be a logic case to me. But I will think it through. I will discuss with Xin offline on that. All right, we are close to 58 minutes mark, so we probably won't have enough time to discuss the white paper thing. I guess we just sync offline, Xin.
Yeah, that's fine.
All right, any questions?
Hey, Sean, what's
No?
next for the container notifier? You know, how's it kept going? Is it still under review? We need more feedback.
That's a great question. So I'm from my side, I'm pushing API reviewers to take a look at it because this involves a lot of change. Xin and I already got at least a bare minimum consensus from most of the major reviewers. We just need to push them to do the work and sign it off. But I need to take part of the plan because I was not having enough bandwidth to work on that in the past quarter or so. So this is slightly off the schedule.
So I think it's already updated. There are just some, looks like some formatting issues, but I think we can probably go ahead and pin the API reviewers to take a look just to see if this is what they expected.
Yeah, well, I have updated the cap. What I was saying is that, this cap has been there since January or something, right?
Yeah, there was a,
Yeah, there was a good amount of time I didn't get enough time to work on that.
We're all busy. It's okay. No blame.
Oh, that's okay. I take the blame if there is. All right. Thank you, everyone, and have a nice day.
Thanks.
Thank you.
Take care.
Bye.
Thank you.
Bye-bye.
Bye.
Right, thanks.